third methodology that will be explained here is input-output analysis, or IOA. In brief, input-output analysis is a macroeconomic tool that provides an overview of an economy by examining what we call an input-output table. An input-output table is what you see here on your screen. This is a simplified version. Over here, and an input-output table is a symmetrical table where the sectors of one economy are listed in the same order, both in the columns and the row headers. The values inside of the table are monetary or physical transactions from one sector to another. Therefore, it explains what one sector sells to another, to all other sectors, including itself, as well as all the inputs needed from one sector in order to produce its goods and services. This inputs needed from other sectors is called the production recipe. Over here we have listed three fictional sectors of one economy: the sector of sand, the sector of concrete, and the sector of steel. The column of this table shows the production recipe of the three economic sectors. In other words, if you remember, the inputs needed from one sector to produce its goods and services. For example, the value circle in red, so 30, tells us that the steel industry bought 30 units of output from the sand industry. Also note that if we add all the inputs found on the rows and all the outputs found in the columns, we come to the same result. This means that input-output tables are a closed system in equilibrium. In other words, input-output analysis is a mathematical tool that helps to look at the interaction between economic sectors. A more advanced version of the previous table is what we call a multi-regional input-output analysis table, or input-output table. The previous example showed the transaction of sectors within one economy. Multi-regional input-output analysis not only looks at the transactions of economic sectors within one economy, but also the transactions with other economies of other cities or countries. In this table, you can find the input-output tables of region 1, 2, and 3 that are outlined in red, in the red boxes, but also the transaction between regions, between region 1 and 2, 2 and 3, and 1 and 3. The blue box shows how much region 2 has bought from region 1. The green box represents how much region 1 bought from region 2. This multi-regional input-output table and analysis helps us to take into account entire supply chains of each good and service consumed by a city. Therefore, it includes all of the indirect flows of urban consumption. The data required to perform an input-output analysis are often provided by national statistical offices. For multi-regional input-output tables, they are often compiled by different research consortia, and you can see some examples here. This means that at best, the advantages of using input-output analysis are numerous. As this method covers the entire economy in a systemic way, it helps to understand the complex links and interrelationships between economic sectors. Through the use of multi-regional input-output tables, it also becomes possible to take into account indirect effects that happen all over the world. This means that input-output analysis helps to measure the full impact of cities on the global environment. Unfortunately, input-output analysis also presents a number of disadvantages. First, there are very few cases where input-output tables are available for cities. In general, they are only available at a national scale. This means that in most cases it is assumed that economic sectors of cities have similar production recipes as countries. The second and perhaps most important limitation of input-output analysis is the uncertainties of the results. As the indirect effects can be physically measured, can't be physically measured, it is difficult to validate them. The third limitation of input-output analysis is the time lag of input-output tables. In general, input-output tables take 5 years to be constructed. This means that at best, you can assess your city every 5 years with 5 years of delay. In addition, this implies that if you implement a policy today and wish to see whether it had a positive impact in 5 years' time, you'll have to wait at least 10 years to find out.